All right, so again, this is the Module 5 review. We already did a video going over question 2. This video is going to go over questions 7 and 8. So the first step for this is actually identifying how the diagram is set up. So two planes at the same altitude, meaning they're the same height off the ground, approach in the same direction. One plane is 24 miles from the control tower, so this is the tricky piece. That 24 is this distance. So let's go ahead and label that. That is 24 miles, not the ground distance. That's the common mistake there. The other plane is 35 miles. So that is the straight distance. If we were to like tie a string from the plane to the airport, it would be 35 miles. How far apart are the planes? So we are ultimately looking for this distance. I'm just going to redraw this triangle so we can hopefully see it a little bit clearer, that we are in fact going to be using the law of sines and cosines. So we are looking for this value. We know that this is 24. We know this is 35. We know that this is 15 degrees. We're going to end up using the law of cosines, which will be provided on the final exam. The formula for law of cosines is a squared equals b squared plus c squared minus 2 times b times c times cosine of big A. A, B, and C, lowercase, are just the side lengths, and the big capital letters are the angles that are opposite each side length. So the fact that I'm looking for this side, I know its opposite angle. I'm going to work with this and just fill in the blanks. So x squared is equal to 24 squared plus 35 squared minus 2 times 24 times 35 times cosine of 15 degrees. I'm just going to type this entire thing into my calculator to see what I get for x squared. So just give me 1 second, I'm going to pause it. Alright, so once I type this into my calculator, I get 178.244. I'm not going to clear it out of my calculator. I'm just going to go ahead and take the square root of that previous answer, and I should get x is equal to 13.35 miles. Rounding to the nearest tenth, 13.4 miles. That's how far apart the planes are, using the law of cosines. Sweet. For number 8, a hot air balloon is being held down with 2 ropes of different lengths that are tied to 2 stakes that are this far apart. The angle of elevation opposite the shorter rope is 52.4 degrees, and the angle of elevation opposite the long rope is 74.5 degrees. The ropes are taut, meaning there's no slack. Find the length of each rope, and then find the height of the balloon. So we have this nice diagram here. We actually know angle C. We could figure this out just by doing the 180 trick. All angles add up to 180. So 180 minus 74.5 minus 52.4, we get 53.1 is the angle inside there. And now we should label our sides. So this rope right here is going to be little b because it's opposite big B. This rope right here is going to be little a because it's opposite big A, which makes this ground distance little c. We know the entire C piece. We know the C side and the C angle. So since we know an entire chunk, we're going to work with the law of sines. And I'm not going to write it all out. You'll be provided it on the formula sheet, but since I know the entire piece, let's go ahead and just find side length A. So A, little a, over sine of big A is equal to little c over sine of big C. Just fill in all the gaps. I don't know little a divided by sine of big A, 74.5 equals little c, we know, 1526, all over sine of big C, which we now know, 53.1 degrees. To solve for little a, we just multiply both sides by sine of 74.5, 1526 times sine of 74.5, all divided by sine of 53.1, and we get little a is 1838.84. 1838.84. And we're in meters, so meters. I'll write it down. 1838.84 meters. Great. We are going to redo it, except this time we're going to find B. So we know this entire C chunk, so let's just rewrite that. 1526 over sine of 53.1 equals little b over sine of big B, which would be 52.4. 52.4. So that means little b is going to be equal to 1526 times sine of 52.4, all divided by sine of 53.1. And we get 1511.89. 1511.89 meters. That's little a, that's little b. I'm not going to write it right there. All right, so check. We found the length of each rope. Last, we need to find the height of the balloon. So let me just change colors. We are looking for this height. Well, I'm just going to work with the triangle that we now know everything about. This triangle, because that blue dashed line, the height, does make a right angle. So let me just redraw that triangle over here. We are looking for the height. We know that this is a right angle. This is 74.5. We now know that this length right there is this one, 1511.89. I'm just going to use my sine function. Sine of 74.5 is equal to my opposite, which is my height, over my hypotenuse of 1511.89. So height is equal to, once I multiply both sides by 1511.89, we get 1456.9. 1456.9 meters. That is our height. Let me know if you have any questions.